In Chapter 5, we're going to talk about epidemiology. And epidemiology is basically a study where researchers try and look for associations and prevalence, or how often a disease is actually occurring. So with the term epidemiology, you kind of break it down and you think that it possibly means epidemic, but it really doesn't mean epidemic. It really means epidemiologists kind of look at something called endemics, which endemics are diseases that are occurring kind of steadily in a group of people, whereas an epidemic is large amount of cases, or I should say are large amount of cases that are occurring and that it's widespread. But epidemiologists really kind of look at what diseases are out there that are occurring frequently, and they try, and again, like I said, they look for associations between variables, and they also want to look at prevalence, how often the disease is occurring. So an overview of a few things that we're going to be looking at in Chapter 5 is prevalence, risk factors, risk ratios, risk odds ratios, and a couple different types of studies that scientists or researchers do to try and identify prevalence and risk factors within diseases. And one would be case control studies, and the other is cohort studies. So some definitions that are important for us to know when we're talking about epidemiology is prevalence, which is the proportion of existing cases of a disease in a population in a specific time period. So you're looking at old and new cases, but identified within a particular set time period. If you're looking at a study, it may be, you may want to look at how many cases of influenza we saw in Stark County from January 1st of 2015 to December 31st of 2015. So you would look at all the old cases that have been accumulated and also cases that are going on right now. And that identifies basically the prevalence of a disease. Incidence is a term that is misused a lot of times. When you're looking at an incidence, you're really kind of looking at the new cases, the number of new cases of a particular disease that occurs. And an endemic, like I had just explained in the previous slide, or 2 slides ago, endemic is a disease or condition that persists within a geographic area. And an epidemic is a disease that's widely and rapidly spreading, and it's a little bit more than just an outbreak, but it's less than a pandemic. And a pandemic is a disease that usually is pretty rapid, and it moves from, it can go throughout the world. It can move from continent to continent. And a good example of that was a few years ago when we had the Asian bird flu, and it started in Asia, but because of cross-continental travel, we had individuals pretty much all over the world coming down with this Asian bird flu. So that's pretty much what you're going to be thinking about with a pandemic, which we'll define in another slide. But an epidemic is really widely, rapidly spreading disease very quickly. So another important definition for us to know is etiology, which I'm sure most of you know what etiology is, because most of you have had your biology or microbiology courses where they talk about the different etiologies of diseases. And it is basically the cause of a disease or the condition that you're studying, and it's the first steps in the natural history of a disease, meaning what actually is the cause of that disease. So what's the virus or what's the bacteria that causes a disease? The etiology of chickenpox is the Varicella-Zoster virus. So that would be the etiology. That's the actual virus that causes it. Shingles, which everyone thinks is directly, like the adult form of chickenpox actually is the herpes zoster virus. So you can see that they have, in most actual diseases with bacteria or viruses, they have identified what the etiology is. Most of them they have. An outbreak is two or more illnesses that are linked to a common source. So in outbreak, the one thing that I always think about is an outbreak of food poisoning or an outbreak of E. coli. Once you have two or more individuals that have been affected by a common source, say, go back to think, a lot of you are probably too young for it, but if you think back on the outbreak at Chi-Chi's that happened probably 10 years ago, and one person got sick at a restaurant, not a big deal. Second person got sick, now we have an outbreak. So we have two or more individuals that are linked to a common source, and in this situation, the common source was Chi-Chi's, and then what they tried to do was identify what all these individuals had eaten, the ones that had got sick. They wanted to know what they ate. And I can't 100% remember, but I want to say it was definitely a fresh vegetable, either lettuce or tomato, that they had received that came in, had E. coli, and they had no idea, served it to the individuals. Huge outbreak, basically put Chi-Chi's out of business as far as the restaurant goes. So that's what an outbreak is. You have to have that common source. Another example would be when you maybe eat at a salad bar somewhere and you get sick, and say the other four people that you went to dinner with and ate at the salad bar got sick, then that's an outbreak because there's something going on. It's not all 4 or 5 of you have the stomach flu, you've eaten something to make you sick. Then they identify that as an outbreak. And pandemic, like I had described earlier, is widespread epidemic, usually affecting several countries and sometimes infecting the entire globe. And a couple more definitions for us to look at is morbidity. And morbidity identifies the relative incidence of a disease, how many new cases of a disease that a population is affected with. That basically someone who is sick or has something, they've been diagnosed with a particular disease, that's a morbidity. Now the mortality is pretty much, everyone knows mortality. It's the number of deaths in a given time and place. How many deaths have we had to malaria? How many deaths have we had to HIV? And that would be within a particular area and a time frame. That's how mortality would be identified. And calibration, very important. That's basically an agreement with a set of standards that all individuals that are participating have agreed upon and that they're going to use. And calibration is very important in identifying any sort of raw data that has been gathered, that how the data has been gathered the same across the board. There are no variations in order to make sure that that research project is calibrated. It's determination of accuracy and consistency between examiners to standardize procedures and gain reliability of their recorded findings. So calibration, a rubric basically is a calibration. So when an individual is taking a course and a rubric is provided for, especially for answers that you are stating from your knowledge, the rubric can identify where you are with how much knowledge you have gathered. So everyone is graded on the same basis based on that rubric, not based on what the instructor thinks or how the instructor feels about the student. So it's all done through calibration. So identifying prevalence is basically looking at the frequency of disease cases in a particular population at a particular time. So basically, prevalence is exactly what it sounds like. How often is this disease occurring? And prevalence is usually always expressed as a proportion, something into something else. And usually it's the number of people in a sample with a disorder or with a disease divided by the total number of sample, or I'm sorry, total sample size that is being worked with. Okay, and then of that, you multiply it by 100, and it's always expressed in a percentage. So in the example shown here, if you have 37 cases out of a sample of 250 individuals, the prevalence of that, or how often that particular disease is occurring, is 14.8%. So it's pretty simple concept, but you're looking at how many cases within a group and multiplying that by 100 and then expressing that into a percentage. So some of the problems in estimating prevalences is you really do need a large sample to be representative of the population. So it can, there's some problems that can occur with individuals that may be biased, and they may, be refusing to participate, and also individuals that possibly have the disease or have the disorder, they may be less likely to be, knowing they have the disease, they may not want to participate. So sometimes you can have problems gathering information in a particular group because individuals don't want to come forth saying they have a particular disease. So you can have some measurement inaccuracies there. It's kind of like if you have, say you're going to do a study on how many outbreaks of the flu on the east side of Cleveland. Well, that isn't really going to give you an accurate reading as to how prevalent the flu is, because there may be an outbreak on the east side of Cleveland that there isn't on the west side of Cleveland. So without encompassing the whole area of Cleveland, you're going to have inaccurate results. And more confidence in prevalence estimates if there's an agreement across several studies, meaning that if there's different studies that are taking place and we're going to assume the prevalence estimates that we have, that we're agreeing that how you gathered those prevalence estimates are going to be considered in our research project. So you have to have basically an agreement throughout several studies that how you gathered that information is how you would normally gather the information. There wouldn't be any variation from it. Another area that epidemiologists look at are the risk factors that are involved in diseases. So we've all read studies, we've all read journal articles, we've read articles in the newspaper, and pretty much some of the main causes of death in the United States, we know the risk factors for. We know the risk factors for heart disease. We know the risk factors for stroke. We know the risk factors for particular types of cancers. So that's a lot of what epidemiologists look at. And many of the diseases associated with a range of factors that are neither necessary nor sufficient to cause the disease, but exposure increases the onset of the disease. So I always use the example that when I used to teach the class in the actual classroom, for years I taught pharmacology to all the health profession students. And it was an 8 o'clock in the morning class, and the classroom was filled with students. We usually had 35 to 40 students in there. I had to shut the door because it's in a very noisy hall, and there were always, at every given point in time, there was always 5 to 10 students with a cold, a cough, sneezing, rubbing their nose, blowing their nose. And when I worked in that environment, the more I was exposed to those kids, I usually always ended up having some sort of a upper respiratory infection, because the more I was exposed to it, the more that's going to increase the probability that I'm going to get the flu or the upper respiratory infection. Now I'm not in the classroom. I don't want to say it because now I'll probably get a cold, but I usually don't get sick because I'm really not in that environment where the more I'm exposed to something, the more of a possibility I'm going to actually get it. So what epidemiology tries to do is identify risk factors and what contributes to the actual disease, and then understand what causes, like what are some of the causal mechanisms that put one person more at risk of coming down with the disease versus another individual. So, and I want to just also say that this is just a tiny little bit of epidemiology. You will, as an allied health student, have a whole course on epidemiology, which is a fabulous class, and you will learn so much from it. And it just gives you so much information, how to figure out, how to calculate, your prevalences and your risk factors and who's at more risk. It's a very good class. So this is just a little bit tip of the iceberg for you, so you maybe have a little tiny bit of knowledge going into that class, but it's definitely a very good and a very beneficial class in this program. So one of the studies that can be used to identify different risk factors for particular diseases is something called a cross-sectional study. And the cross-sectional study is a study that you're going to measure risk factors for a disease at one single point in time. It's not going to be something where you go back in history and carry it through till now and possibly into the future. You may look at one single point in time. You may want to look, once again, like I used the example earlier, of looking at January 1st to December 31st. That may be that single point in time that you want to identify how many cases of influenza were reported in Mahoning County. So it's one point in time, it can be behind you, but it's only one point that you're actually looking at. You're not going to carry that study out over years. And it tests the association between risk factors and diseases. And so doing cross-sectional studies, you may want to identify what the risk factors for that particular group of people that had influenza Were they, in a classroom? Were they, healthcare professionals? Where they didn't have the flu shot, or did they have the flu shot? So these are all factors that you may take into consideration. Then what you would do would be analyze that data based on the questions that you were identifying, and then you can come up with potential risk factors. And understand also, you can, how many times have you heard of somebody that gets lung cancer and never smoked? Okay, we all know that the risk factor for lung cancer is smoking, but there may be other potential explanations as to why that individual would get lung cancer. Okay, so it doesn't necessarily mean that they're smoking. Back in the day, when you used to be able to smoke in restaurants, you would see a lot of waitresses come down with emphysema and lung cancer, but at the time we didn't realize they weren't smokers, but they still were referring, or they were still inhaling this secondhand smoke that was obviously causing lung cancer and emphysema or COPD in these individuals. But at the time, looking at it, we would say the risk factors for that individual is kind of weird because they didn't smoke, because that was pretty much the primary risk factor in the past for lung cancer. So where I'm getting at with all this is there can be other potential explanations as to why an individual would get a disease. It does not necessarily mean because they have the disease that they also have the risk factors involved for that disease. A lady that I worked with that was an advisor, little, tiny, thin, very healthy, walked nonstop, was diagnosed with type 2 diabetes. She had absolutely no risk factor for type 2 diabetes, but she came down with it. So, why? She wasn't, elderly like you would associate it with. So, there really was no potential explanation up front that we know of right now that someone like her would come down with the type 2 diabetes. So looking at our risks, we always want to display risks for a particular disease in a ratio form. And what we do is we're comparing the disease in a group that has what we would call the hypothesized risk factor, the risk factor that we think could possibly be associated with the disease. And we compare that group to the risk of those who were not exposed to the disease. So individuals that, all the kids that sat in the classroom with me and never got sick versus the ones that did get sick. So given these numbers that are just an example, if you had 0.024 for your exposed risk and versus the unexposed risk of 0.004, your risk ratio would be 6. The exposed people are 6 times more likely to have the disease than the unexposed people. And a risk ratio of 1 usually indicates that there's no link between the factor and the disease. Okay, so if you're right about 1, that's really not showing much at all. It's pretty equal, actually. And an odds ratio, and we're not going to get a lot into the odds ratio, the probability that an event will happen divided by the probability that will not happen. So we're kind of looking at, once again, our risks, but odds are that the probability of an event will happen divided by the probability that it won't happen. Odds ratios is the odds of the disease in an exposed group divided by the odds of a disease in the unexposed group. Very similar to risk ratios, but they're just kind of looking at the odds that it will or won't happen. And another type of study that we can look at to identify prevalence is a case control study. And case control study is basically what it says. We're controlling the groups of people or the individuals that are in our study. You cannot estimate disease prevalence in a case control study. You can identify risk factors. So you're not really looking at prevalence in an estimation form, which is how we identify prevalence anyhow, is through estimates, but we're going to identify risk factors. And the recruitment of individuals is basically you're going to take a sample of a group of individuals that have the disease that you're looking at, and you are going to compare that with a matched sample of control group. A matched sample meaning the same amount of people or the same amount of individuals in a control group. And you're going to compare the risk factors that those individuals have in that particular group. So it's controlled. You're going to have a couple different groups of people, and you're going to look at the disease of interest, and you're going to look at the other group that you have more control over that group. And once again, you're only going to be looking at the hypothesized risk factors. Another type of study that can be done is something called a cohort study, and a cohort is following a particular group over a period of time. When a lot of closed medical programs, they say they enter you into the program as a cohort. So you stay together over the group that you start with, you finish with. That's a cohort. The example that the book talks about is, and they talk a lot about the UK, the United Kingdom, and the reason is because the authors from this book are from the United Kingdom. So they talk about the National Child Development Study, where they looked at 17,000 individuals born in 1958. Then they studied them at birth. Then once again, they studied them at the following ages of 7, 11, 16, 23, 33, 42, and 50. And if, say, they were studying a heart disease, progression of heart disease, and risk factors of heart disease, they would know that at birth the child does not have coronary artery disease. So they can study that individual in this large group and then look at risk factors throughout the years, and then look at them at different ages when they developed heart disease. Okay, so that's a cohort. You're going to start and you're going to follow that individual for a period of time. Cohort studies in causes for different diseases are very important, because you'd like to look at, in a cohort study, you like to look at the individual before the disease has begun, so that you can kind of, and hence the study for the children in the UK. They looked at before the say, I'm not sure it was cardiovascular disease they were looking at, but they looked at that child when it was a, pure newborn baby with no diseases. So it was prior to diseases starting, so that it was easy for them to identify over the period of so many years when diseases began, in identifying the risk factors for the particular diseases. A lot of what a cohort study can do also is it can rule out the possibility that your hypothesized risk is really is a factor of basically of the outcome of the disease. So you can come up with a hypothesized risk that you believe being exposed to, I don't know, lead. Being exposed to lead is going to cause coronary artery disease in children. Well, by doing this cohort study, they can study over a period of time, and they can really identify that no, that isn't going to be really a risk factor for heart disease, just based on studying this particular group of people. Okay, but what it does kind of look at is there can be other reasons, like I had said before, just talking about the lung cancer, there can be other reasons that we would call a third variable problem that would be associated with a particular disease, even though it's not a hypothesized risk factor, or even though it's not a known risk factor. There could be another reason that we aren't aware of yet, and that's called basically a third party or a third person variable problem. And some really good studies for a cohort study is an experimental study and randomized controlled trials, where you randomly select people, but yet you control that group. And in order for you to see if there's strong causal evidence that something caused something, an experimental study is really ideal. However, like we talked about early on in the semester, there's a lot of ethical and practical constraints when you're doing experiments on individuals. So you don't, unless that experiment is going to, the benefits are going to outweigh the risks, the researcher would have a really hard time getting approval from the internal review board saying that it's okay to do that study. And I talk about humans, but I also want to throw in there the internal review board. Also, they regulate what people do to animals too, through experiments, and through a lot of the organization PETA has really cut down on what experiments that researchers can do on animals, because it's unethical. So you can kind of look at a lot of the experimental studies that are done on individuals that have cancer, and there really has not been, they're kind of not going to react to the medication or to the chemotherapy or the therapy that they have been going through, and the only alternative is for them to die. They would be a good candidate for a particular experiment, say using chemotherapy or radiation treatment or such, that they had no other choice but to take this treatment. So it's not going to really cause them harm, because the end result for this person anyhow is death. So a summary of what we looked at epidemiologists and what they do, study different patterns of disease and health, looking at prevalence and risks in estimate form, and trying to identify what actually could be a risk factor for a particular disease. Like I said, there can always be that varied third-party variance that even though you think you know everything that causes the disease or is a risk factor for the disease, something else, there could still be something else out there that would cause that particular disease. Various approaches that were employed, including general population, case control, and longitudinal studies. We looked at all of those basic concepts of estimates, prevalence, and risk factors.